Okay, guys. Sorry we have a short week. Figure maybe more of you guys will come online. For those of you who just come online just to learn, I'm also a math teacher at a high school in Queens, and I am doing remote learning with a lot of the students. So please just bear with me. So this is the worksheet that I did hand out. This is found in jmap.org. This also covers the topic of standard deviation through the use of normal distribution. All right, so let's look at the question and see if we can get through these answers. All right, it's fairly simple. Shouldn't take any more than, like, say 10-15 minutes at most, maybe less. Okay, so let's start. So suppose two sets of test scores have the same mean but different standard deviations, sigma 1 and sigma 2, with sigma 2 being greater than sigma 1. Which statement best describes the variability of these data sets? All right, so obviously data set 2 is going to have a greater variability because the sigma represents the standard deviation. The standard deviation is a deviation from the norm. See, I have a normal curve like this right here. A deviation from the norm right here is sigma. This happens to be a negative sigma. This happens to be a positive sigma. Right? So if we look at our answer, it's 2. Data set 2 has the greater variability. Question 2. On the standardized test, Kathy had scored a score of 74, which was exactly 1 standard deviation below the mean. If the standard deviation for the test is 6, right, what is the mean score? It's 2. Answer is 2. Okay. So the standard deviation, they give you a mean of 74, right? And it's saying it's 6. So minus 6. Actually, this works out fine here. Okay. So minus 6. Sorry. 74 is right here, and that's a standard deviation to the left, which is going to be minus 6, so it's going to be 80 right here, right? And then right here would be 86, right? So 1 standard deviation, so the positive standard deviation is the negative standard deviation. So that's going to give you 74. That's going to give you 80, sorry. That's an answer. Right? Because you look at it, it goes up 1. Simple. Straightforward stuff. Right? On a standardized test, a score of 80. Hold on one second, guys. Sorry. So on a standardized test, a score of 82 falls exactly 1 standard deviation below the mean. So 82 is 1 below the mean, right? So the standard deviation for the test is 4, right? So we're gonna have 86. Right? It says 82 plus 4, which is easy, right, guys? 3 says on the standardized test, Phyllis scored. Sorry, let me move that over. 6. Since Phyllis scored 84 exactly, 1 standard deviation below the mean. If the standard deviation for the test If the standard deviation for the test is 6, right, what is the mean for the test? So she scored an 84, exactly one standard deviation. So the mean for the test was 90. 84 plus 6. Next one says, on a standardized test, a score of 86 falls exactly 1.5 standard deviation below the mean, right? It's halfway between 2 and 3, right? Or halfway between, sorry, 1 and 2, right? So if the standard deviation for the test is 2, right, what is the mean score for his test? So in other words, you normally go 2, right? But 1.5 is giving you 86, right? So the person scored, let me erase this right here. The person scored an 86, right? Falls exactly below. Okay, so this is standard deviation 1, this is 2 standard deviation, right? 2 sigma, that's what I'm drawing, 2 sigmas right here. 2 sigma right here, right? Right there. That's essentially, so it's right here. The person gets an 86, right? 86, so that's a 1.5 right here, right? If the standard deviation for the test is 2, right? What is the mean for the score? So okay, so the mean is going to be, all right, so let's work this out, okay? Right, so it's 86 right here, right? So that's exactly 1.5. So and standard deviation is 2. So the standard deviation should normally be, standard deviation for the test is 2. Sorry guys. Standard deviation normally is 2, right? So what are we looking at? 88. Hold on a second, guys. Give me 1 second. Right? Let me just work this out. It's a lot simpler. Let me pause for a second, guys. Okay. Let me pause for 1 second. So think about it. Standard deviation will be 2, right? And they tell me that 1.5 standard deviation is going to be 86. So one and a half away from it is 86, right? So that means that the normal standard deviation, or the normal distance from the mean in this case, would be 3. So it's 2 times 1.5. I'm going to add that to this right here. 86 plus 3 is going to equal 89. Is it back? Just looking at the delay here, guys. Sorry. Okay, all right. So, sorry. Okay. So now it says on the standard for 6 says on a standardized examination, Laura received a score of 85, which is exactly 2 standard deviations above the mean. You probably exactly 2 standard deviations above the mean, right? Standard deviation of the examination is 4, so that means it's 8. So 85 minus 8, which gives me 77. So it's above, right? So it's 2. So this right here is 89 right here. This is going to be 85 minus 8 equals 77. 77. In the accompanying diagram, the shaded area represents approximately 95% of the scores on a standardized test. These scores ranged from 78 to 92, which could be the standard deviation. All right, so the standard deviation, well, if it's 95%, right, so that's within 2 standard deviations, right? So it could be within 2 standard deviations from it, right? So if the scores range from 78 to 92, so from right here to here, say it's 85 right here. Right here to here would give me 7. From here to here would give me 7. So, which could be the standard? So we want to know, once this is 2 standard deviations. 2 standard deviations make 95%. Make that a little clearer for you guys. 85 right here. So 2 sigma will be equal to 95% confidence. I explained it before. If we're looking at a normal distribution of chances of an event happening, right? One standard deviation from the mean would be 66% chance of things happening. 2 standard deviations from the mean, right? Let me solve this right here to show you guys. So this is a normal curve distribution, right? This is what test scores would be. So if we're looking at right here, say this is your mean mu, right? Right. So 1 standard deviation from the mean, so from here to here, means 68%. Right? I believe that's what I said. Now 2 standard deviations, right? In the direction. Oh, come on. 2 standard deviations, right? Oh, come on. 2 standard deviations. That's 95% confidence. This is mu. All right. This is 95% confidence. And now 95% confidence is 2 standard deviation or 2 sigma. So let me go 2 sigma, right? Right here is 1 sigma. 1 sigma. So you look at 95. So this is 2 standard deviations, right? So now we have scores of 78 right here, and 92 right here. So that's 2 standard deviations. So that means 1 standard deviation has to be 3.5 if 2 standard deviations is 7. I don't know if that's clear. If 2 standard deviations is 7, so in this case, 2 standard deviations will equal 7. So that means 1 standard deviation. Would equal 3.5. Equal 3.5. Right? So then we're left with the standard deviation of 3.5. So that's our answer for this one. 3.5, okay? I hope that's clear for you guys. Let me just circle the answers here. Alright, so there's no questions, guys. Any questions? Because I got to start my other class in about 10 minutes. Any questions? Any questions at all? No? No? Alright, so if there's no questions, guys, or if there is a question, please don't hesitate to leave a comment in the comment section. I'll get back to you as soon as possible. Okay? Until then, I will see you guys on Tuesday. I'm going to start to slow down on the live streams a lot. Maybe just give like once a week, especially in this last month of June, since it's pretty much just a review month. Alright, so which will probably just be on Thursdays. So, yeah, if you have any questions, guys, you always feel free to leave it in the stream of the Google Classroom or leave it in the comment section here, these videos. Alright? Until then, guys, I will see you later.